Welcome to What the Fact. Today's topic is this. What you are seeing here is called Cherenkov radiation, named after the Nobel Prize-winning Soviet physicist Pavel Cherenkov, who first discovered what causes it. Cherenkov radiation forms when particles, usually electrons, travel faster than light. And it happens most commonly in nuclear reactors, which release a lot of electrons. Right now, Einstein's ghost is probably standing right over there thinking, "Boy, I will cut you." But I didn't say traveling faster than the speed of light, I said faster than light. Light is carried by massless particles called photons. The speed of light is, roughly, 300 million meters per second. Nothing that has mass can travel at the speed of light, and nothing at all can travel faster than the speed of light. Photons, because they are massless, always travel at the fastest possible speed. In the empty vacuum of space, they travel at the speed of light, which is abbreviated c. They can't go faster or slower than that, just that speed. But when light travels through material that has mass, it slows down. In water, photons move at about 0.75 c. That doesn't mean the speed of light is different, it just means light itself, the speed of photons, has slowed down. And in water, electrons can move faster than 0.75 c. I don't have a strong background in physics, but I read carefully, and this is what I understand is happening. Water is a polar molecule. It has positive and negative regions. This is caused by the electrons crowding to one side most of the time, and electrons are negatively charged. When an electron passes by these water molecules, it causes them to move slightly, like a magnet passing by and making other magnets flip. The water molecules then go back to their previous state, but that requires energy. When the water molecules go back to their lower resting energy state, they have to release energy, and that comes in the form of a photon of light. You can think of it like an object cooling down. As an object cools down, it goes back to a lower energy state, but it must release energy, and that's what the heat it releases is. Under normal circumstances, the water molecules release the photon so quickly that it isn't noticed. But when the electron moves through the water faster than the rate at which the water molecules can go back to their lower energy state, the photons pile up. This is exactly like a sonic boom, but with photons. The reason the light looks blue is that the radiation is very high energy, and blue is the color of light with the shortest wavelength. Most of the radiation is not visible. It's ultraviolet. Bonus fact: why isn't the light purple or violet? Roy G. Biv is a lie. There is no violet in a rainbow. None. Violet and purple are combinations of blue and red, two colors on opposite sides of a rainbow. That color doesn't exist in the electromagnetic spectrum as a pure wavelength of color light. If you haven't already, click on the link in the description for this video to visit my Patreon page, or just go to patreon.com/planetpeterson. Your support allows me to keep making videos and improves this channel in so many ways. You can contribute for as little as 10 cents a day. There are added benefits to being a Patreon member, including suggesting topics for future videos, early access to videos, and more. Make sure you're subscribed to this channel and hit the bell so you can be notified when new videos come out. That way you can be one of the very first to view and comment on the video, which makes it way more likely that I will see your comment and be able to respond to you. You can also find me on Facebook, TikTok, Instagram, and Twitter by searching Planet Peterson. I'll see you next time.